Hello, I'm Jeremiah Bernau, a PhD student at the University of Utah, and I'm happy to present today Dr. Gregor Eberli, SEPM's 2022 Pettijohn Award winner. I'm a geologist that works on the Bonneville salt flats, which you can see in my background here, and my research focuses on understanding how salt and water is moving through this system on timescales of daily timescales, looking at things on the hourly timescale across several millennia. In addition to that, I look at how the deposition is changing in that system with water moving across and how that influences evaporite deposition on the multiple feet scale, as well as laterally several hundred kilometers, all the way down to the thin section sample. So I'm very excited today to talk to Dr. Eberli, who is also someone who works on chemical sediments. So first of all, today I'd like to ask you, Gregor, could you summarize your career for us?
Yes, I can. So I'm from Switzerland, and I did my undergraduate and graduate, also my master's and PhD at the ETH in Zurich, which is the Swiss Technology Institute in Switzerland. And studied for my master's, I mapped the boundary between the ocean and the continent that is crumpled up there in the mountains in Switzerland. And then for my PhD, I looked at the evolution of the rift basins in the Jurassic when the Tethys Ocean opened, and reconstructed the opening dynamics of the Tethys in that part of the world. Then I came as a postdoc to Miami, worked with Robert Ginsburg in the comparative sedimentology laboratory. And while I was here, the first seismic line from across Great Bahama Bank became available. And so I started to work on those. And it was quite an eye-opener because for the first time we saw the internal architecture of this huge bank and realized they're actually built by a smaller platform and that have grown together over time. After 2 years, I went back to Switzerland at a position at the ETH for about 4.5 years, and then the faculty position became available in Miami. I applied, I got the position, and I've been here ever since, except in 2000. I was for a year working on a sabbatical in the Shell Research Lab in Dreisweg. There they just started to build a new carbonate research group, and they invited me to join them for a year. It was very exciting, I have to say. And then I came back and continued to work here. Robert Ginsburg then gave me over the comparative sedimentology laboratory, and we run it together with our colleagues here. I'm the director of that, and we have chemical sedimentologists, stratigraphers in the group. And actually 2 years ago, I also became the Robert N. Ginsburg Endowed Chair here at the University of Miami.
Excellent, thank you. I personally got to enjoy a trip to the Bahamas, and I think I remember looking at some of your work with those seismic lines, and it's really incredible putting the two both together. So what are you most proud of in your career?
Well, I think most proud of in my career I am of my students. I had 22 PhD students, 11 master students from 14 different countries, and I'm pretty happy and proud that they all finished, got jobs, and I sent them off on their professional career. I also have to say there are like quite a rewarding element in my life, the students, how they bring a lot of research ideas to me, and so that's what I'm proud of on a personal level. Scientifically, probably the most proud of I am to be able to propose, execute the ODP Leg 166 to the Bahamas, because we, together with Don McNeil and Peter Sword, we put in a proposal, then we got money to go to the seismic site survey. And that was quite an experience because, yes, I had done a little bit of seismic single channel and all that, but that was a multi-channel seismic survey. And it was quite an undertaking, and it was touch and go that we succeeded. In hindsight, I thought we were pretty lucky that we succeeded, but we got the seismic data together, and then our leg was scheduled and we drilled successfully the Bahamas transect, completed that whole transect out there. That was sort of, I think, the most challenging and the most rewarding that I've done in my career as one portion. My wife, however, says, well, I think you're known as porosity, velocity. She thinks my petrophysical work in carbonates really made me what I am today. And I have to say, maybe I was always a bit on both sides, doing the sedimentology to petrophysics and geophysics throughout my career.
Wow, that's an impressive amount of things. With all of those projects, did you encounter any setbacks? And how did you address those and use them to your advantage if you could?
Well, setbacks you always have in a long career like I had. It started very early on when I started at the ETH. You know, ETH is sort of a pretty demanding technical university. And so I came from the rural part in Switzerland, from where the high school was mostly on languages, based on languages. You learn 4 languages, and it was not very well prepared for the math physics skill that were needed for the ETH. And so I failed an exam, and then I had to decide, what do I do now? And I said, either I stay with geology or I quit. But then I decided to stay. I worked harder and went on, and this became better and better. And I went, to study geology and finish it and become a geoscientist. And of course, once you're in your professional life, each time you write a proposal, it might be turned down. Well, we have to do it again, and eventually it will get funded most of the time.
Thanks. So geology was something that you had to really work at throughout your career. And so I'm wondering, with that, did your passion for geology develop through those things, or is it something that developed over time as you did it?
Well, it was on pretty early on, I should say. Once I was into it, I was very passionate from the very beginning on. And that kept me in the studies that make me want to finish that. That's why I decided to do a PhD, and that's why you stay in the science field. So it was maybe a bit more, what came over time was that I realized I really want to do scientific geology, so go into academia. And that was also based on the passion I developed for understanding the Earth, understanding the processes that form the Earth.
Thanks. With your career, are there any things that if you could change, would you? And what might those be?
No, not really. No. I think of my choices at the time to go back to Switzerland when I had my postdoc here. That was nice. I worked down in Italy. It was really nice going back to the ancient rock record, and then coming back to Miami was a great decision as well, because in the United States, it's like, as a young scientist, I think it's very rewarding, very nice to work, because as long as you have good ideas, you get the money to do your research, and as long as you can produce good research, you actually can do it no matter how young or how old you are. So I was very happy to come back to Miami. A couple of times I was offered jobs in the industry, which I turned down. And the first time I had one of these offers was after my postdoc, when Shell offered me a job in the research lab in Reiswijk. And I was really torn of going there and staying back at the ETH in Zurich. And then I called up Eberli, who was at the time the head of the Shell research group, but just left and was at Rice, and asked him, should I go to Shell or should I stay at the university? And then he asked me, so what kind of position did they offer you? I said, well, as a research geologist. And then he said, then don't take it. If you want to do research, you have to stay in academia at the university. If you want to be an exploration geologist, well, then you should join. So I stayed, and I think that was a good advice, and I'm very happy with where I am.
That sounds like great advice. So it really depends on what you want to take with your career. Is there any additional advice that you would have for students or young or early career professionals?
Yes, I would say don't concentrate on making a career. concentrate of becoming a good geologist or a good professional. Work on your professional life, on what you like in your geology field, wherever which field you're in, and become an expert in that field. And I think the career will then fall in place. I think you don't try to, oh, I have to write 3-4 papers to achieve that or that. I have to do all this bean counting. I think over the long run, it will not be as good as being an expert in the field with the passion and enthusiasm that you have for your profession.
Thanks. So across your career and all the moves and other projects you've had, how have you been able to balance your work and your life?
So yesterday evening, I asked my wife the question. I said to her, so what should I answer to this question? And then she said, I think you're still searching for it. And that's basically true. But I have to say, like it also changes over the lifetime. When I was a postdoc coming here to Miami, I had this project. It was fantastic. It was this seismic line, something completely new, on the cusp of a discovery. I worked day and night to work all these seismic profiles up. It was fantastic. I never missed anything else. Also afterwards, when I was back in Zurich in the early years here in Miami, I basically worked. I worked a lot because I really loved it, and I felt completely content with my life. Then once you get married, or you have a family, no matter how small it is, well, your boundary condition changes. You have other priorities. It's not just a profession anymore. It's also a family that you need to nurture, a relationship that needs your attention. And so you need to rebalance yourself again. And that goes on and on throughout your life. So it's not so, I think you just need to try to find each time the right balance so you'll be happy and content with your life. If you're not, then maybe you don't have it. But also I think, working long hours is okay. I still like to do that. It's also not what gives you stress when you work, at least not to me. It's more like, do I have the funding? I don't have the funding and all this. This doesn't work out. It should have worked out. It's these things that gives you stress, not because you have to work 2 hours longer one day. Oh, the work that can be done. It's like, it's just work. It's not emotionally draining. You know what I mean? So it's really, that is also a bit the difference. Sometimes the professional balance is not so much the work hours, but it's also the stress level that you have in your job that is important.
Okay, so it's a lot of things. So it's the stress in your position and what you're passionate about then. So if you have family and work to be passionate about, figure out what can sustain you for that time. Are there any skills that you think are essential for you in your position, or other skills that are foundational for all geoscientists? I know you said it's helpful to really find what you're passionate about and just kind of zone in on that, but what helps contribute to that?
Well, if you're a geoscientist, I think I went into geoscience or in geology because it requires 3 basic things: math, physics, and chemistry. And in carbonate geology, also quite a bit of biology. So it is this broad spectrum of natural sciences that you need for geology. And I think you should try to acquire as much knowledge on each one of those, because it gives you more wiggle room or more choices in your professional career, that you can go in one or the other direction. And it makes you a more well-rounded geologist if you have all the basic backgrounds of all these different natural science disciplines, and gives you the knowledge base and to produce the good results in your projects. So I think this is something that you really need to do. But then on the other hand, also, I think when you go to geology, once you're there, it's also other things that you need to do. You need to be able to read the rock record. You need to have certain software programs. And now what I see, what I didn't have to learn that much at the time, is other things that you do. The computational aspect of geology has increased quite a bit. At the time when I went to school, computers were not there yet. And now really a lot of our tools are computer programs, computer software, databases, all this that need to be understood. And so I think this is something that you should learn as well, in addition to the natural sciences.
Thanks. I think that's one reason why I was drawn to geoscience too, is we kind of get to do all the other sciences too within it. You don't have to choose one and just get into the weeds, although you can too, and I do enjoy that. With your career, what are some creative ways that you've used to transfer or share your knowledge?
I said, I would always take the students to the field. Huh? So I think once you go to the field, you can show them the rock, you can discuss it. It's like the atmosphere, the way you interact is much better than in the classroom. You can bring your knowledge forward in a beautiful setting. And of course, if you go to the Bahamas, you see the modern processes and all that. It's really very instructive, and people like it and students like it. So I realize, however, that this is it's not always that easy, but I think that was my way of bringing knowledge across. Of course, you need to also be good in the classroom. You need to engage the students and all that. You try to be a good teacher, basically, in the classroom and outside the classroom.
Thank you. In relation to like communicating with students in and outside of the classroom, what are some ways you think that we can improve our communication of geoscience to the broader public and increase our outreach efforts?
Well, I think nowadays we have social media. And so last year you were in front of the Great Salt Lake. Last year we had our summer class was out in Utah, and we went to the Salt Lake and went down and all. And one of our students, she made a TikTok movie together for one of our field trip leaders, and designed all that and put this all together and put it onto the web. Well, within the 3 weeks that the field class lasted, it has over 300,000 views, 80,000 likes. And I think this is really, it was quite mind-boggling for me. I said, who does all this? Who looks at the TikToks? And, well, actually people do it, you know. And I think it's something that we haven't explored that much. And I think more and more of these social media come across. Facebook is nearly gone again, you know. LinkedIn is too professional. I think we have to have other means. But I think Instagram, and the younger students, they all have Instagram, and you know, and I think with TikTok, it's also one way to do it. I think that would be a research outreach vehicle that might be underused as so far, especially from societies and also from us as teachers, I should say. Whereas the students already have fully embraced it. You know?
I mean, I agree. It especially helps when you have a beautiful field site.
Yeah, not only that, I think you can also make, you know, people get very famous with just cooking, you know. I mean, you could, I think you could do it in the lab. You do it all everywhere, you know. It's just the way you do it, I think. You know? It also needs some skills, you know. We're not trained in that, let's face it. Like I would have no idea how to do a TikTok movie, you know. So you students need to help us with that.
Yeah, that is a whole new world of additional skill sets that we can be developing. So what impact do you think geoscience research and practice really has had upon human sustainability? And what resources can we use to capitalize on geoscience and its ability to influence this?
Well, you know, geoscientists, they are a bit, how should I say, there is two sides to the coin when you're a geoscientist. Huh? There's also geoscientist is tasked to exploit the earth, huh? From minerals to oil, all that. And at the same time, the geoscientist is also the person who really loves the earth and wants to maintain and sustain it. You know? So it is like this dual role that we play in the society. And I think you know, now we go more and more away from hydrocarbons, we go to other energies, but then we need batteries, we need lithium, we will increase our exploitation of the earth in that respect, we will create other problems there. So I think we have to be really careful, and that we, in the same time as we try to bring energy to the world, we also try not to destroy it too much. And then, of course, we also, especially in academia, we have for years, we have shown that when we do this, how we change the environment. We have a global change, we have global warming, and we also have shown what the rate of these changes can be, and so that the society can actually adjust to these changes. They haven't listened to us that much, let's face it. So, but that is really what we need to do, you know? And now, of course, we go, well, we have the CO2, the sequestration and storage, I think is one other task that will come to us, that we can really contribute and bring that CO2 back on the ground, despite the fact that we helped to bring it out in the first place. And I think also many countries start to build up radioactive power plants again, nuclear power plants. And so radioactive waste disposal will be with us for generations again. And how hard it is in the Yucca Mountains or in Switzerland, for 20 years, we tried to find the right site, you know, so we will have a lot of work to do to help the society to survive.
Thanks. I think you answered my next question, which was why someone should consider a career in geosciences today. And it sounds like there's a lot of directions and areas we have work to do.
Yes, exactly. So I think the next generation geoscientists will more do the mitigation of the problems that we created by exploiting the earth. And that goes from finding radioactive waste disposals to environmental geology. I live in Florida, you know, and the sea level is rising, and sea level is rising pretty fast, and we will have coastal erosion, all this, and all that needs to be done. And so actually here in Miami, we start a new master's program in environmental geoscience, because that's where the work will be in the future. So.
Thanks. Speaking of the future generation of geoscientists, do you have any advice for them on how they can improve their career prospects, or what's maybe some advice that you've shared with your past master's and PhD students?
So I think whenever you go, well, it of course depends what your career path is. If you go to industry, if you stay in academia, or you start to work for the government, it's always a little bit different. So what I think for all these, what you need is, and what we probably don't teach enough to our students, is project management. I think many students, and we also teach it a bit like this, we give homework and the student does the homework. But I would say every student, if you get involved in a research project, in another project, try to manage it just for yourself. So when do I do what? How much time do I invest? Where do I find the time? And when do I deliver the deliverables? All this is very important. And it's like on the smaller project, it seems like obvious, but you get sort of into the habit of doing it. And so it will stick with you. And once you have a job and you know, you get the first task on your new job and you manage it and you bring it to a conclusion, that helps you for the next project and helps you in your career. So I think this is quite important. And the other thing, of course, is that you always try to increase your knowledge base. Just because you finished your master's doesn't mean that you know everything. And especially now, the discipline is evolving pretty quickly, especially since we go to new tasks that await us. We will have to adjust, and we will have to acquire knowledge over and over again. So you can do that by subscribing to journals, but also now you find everything on the web. Just take your time to go and look for it. I also would say, if you're a young scientist going out there to find a job, it's like you need to be known somehow. So you need to get involved with either societies like SEPM, IES, APG, or other society. You contribute to outreach program that your school or university organizes. Maybe you go to places where no other government, the USGS does functions. You go and participate there, that you get known people and you, and they know you. So I think this is very important.
Thank you. I never really thought about the project management part of things, but from all of my past experiences, like I would say that's possibly one of the #1 skills is being able to figure out what you can deliver and actually doing that. So you were talking about the rate at which geoscience has been changing. Over your career, how have you seen geoscience change?
Well, when I studied, as I said, we didn't have computers. I was the first person at the ETH and the geology department who wrote the PhD on a computer, and it was not allowed. It was not a desktop computer. It was a big mainframe computer. So all these computational skills and data storage that went into there. So you were much more dependent on your visual observation. The observational data was very important. You had much less geophysical or physical data that you could measure, much less chemical data that you could measure. So during my time, the first mass spectrometers were installed around the country, and the first seismic data was collected digitally during my career. And it was not until in the mid-90s that single channel seismic data was actually digitally recorded. Before it was only analog recording. So it's the whole computer-based data access and acquisition has really changed. And one other thing that has changed now is also the amount of data. So the amount of data that we produce and store these days is enormous. And because of that, we will have also in the future, as a student or as a professional, we have to be able to manage databases. We have to go into more database-oriented research. And that is something that is also pretty changing. And I see it in academia as in industry. So like you, we have colleagues in other universities don't even go to the field anymore. They just download all the data from all the people and then they write a paper. So it's like, it's these big databases that are accessed. And of course, NSF is feeding that as well. You have to make all your data that you have produced publicly available so all the people can mine it. So it is like a Bitcoin operation nowadays, where everybody mines all the data that is produced. And of course, that brings the science forward. It's pretty hard for the people who have produced the data with blood, sweat, and tears, but then other people take it, that sometimes it feels a bit, I don't want to do that, but that's the way it's going, I think.
Thank you. So with all of these changes, is there anything in specific that you're looking forward or that you would like to do, building upon them?
Well, that's also a bit, these changes is also a bit of where does geology go from here? I think we see it pretty clearly where it goes in academia. It goes like people go much more back into deep time. 10, 15 years ago, we did paleoceanography and we looked at the Neogene, and then we even zoomed in even closer and closer to mid-Pleistocene transition and all this. We studied all that. But now people also go back in time. So how do these changes go all the way back in time in the early days of the Earth? So this is one area that people work a lot on. And my contribution to that is basically that I look what happens today and can we bring this back to the ancient time. So this, what I call what we have in Miami, the comparative sedimentology. How do we see the signals that we see that we record today? Can we see them way back, or how much can we trust them way back? So this is one thing where I work in and continue to work in. And the other, of course, in geology, the planetary geology will become more and more important. What we know now on Mars and how we investigate Mars is really fascinating. But I personally don't go there. I think there are other people who do that quite good. So I'm in a marine school, so I'm concentrating on the marine geoscience. And I think here in marine geoscience, really the big change over the years has been that we have, for many years, we have always thought, especially in shallow water carbonates where I work, that changing sea level is really the heartbeat or the the factor that influences the sedimentation and the distribution of phases on the platform on and into the deeper basin. And over the last 10, 15 years, we have recognized the role of the ocean currents around the carbonate platforms, around the carbonate shelves and in the basin. And it's really fascinating, the hydrodynamics of the ocean basins and all, even lakes and all that. So things that we have underestimated. I think we have to adjust that and adjust many of our models to incorporate not just sea level, but also currents. And that's where I'm currently working on and will continue to work in the next 3, 4, 5 years.
Thank you. I'm really excited to see where that goes and read the papers. So with my final question is, and after that, I'll leave it open if you have any other things that you want to share, is where do you think are the areas that geoscience could be either bridging the gap between academia, contributing to government, areas that it could be contributing to in society, but it hasn't yet?
In society in general, well, for many years, academic research was very well estimated in industry. And that has changed over the years a bit. So I think it's like the industry, I always say, has sort of left academia a bit. When 20 years ago, basically all the big universities, they have this research consortium that were supported by the industry, and more of those have disappeared, and the ones that are still left are on a much reduced budget. So there is much less interaction with the industry. And I don't think it's so much from the academic side, but more the other way around, as the industry has changed a bit. And I think maybe what you mentioned is that the government takes over a bit more this role nowadays. However, in the government, you know, when you look at the Department of Energy or the USGS or NOAA, they all have their individual tracks also in programs where they do all that. And they don't necessarily involve academia, unfortunately. And I think that's where we should try to give a bit more pressure to these national groups or the government groups, that they would involve the academia a bit better. I think it was better years ago, because the first project I did in the United States, it was a joint project between the USGS, the University of Baltimore, and the ETH in Zurich, where we looked at the Great Salt Lake. My first big research project was in the Great Salt Lake. To look at that time, the sea level, the Great Salt Lake was rising and rising, and we tried to find out how high did it go, and we had looked at cores from the Great Salt Lake and look at the cycles of falling and rising sea levels in the Great Salt Lake, and so there was an interaction much more than it is today. I think, at least here in Florida, I don't know how it is out in the USGS but at the time, there was the lady, Mrs. Atwater. She was fantastic. She's still around, and she was there 2 years ago on the field trip. She brought all these groups together. So it's also a bit the individuals that bring those together. But here in Florida, the USGS is separate from the academia. The NOAA does different things, but each one would have actually room to incorporate more from the academic research. And then we could contribute more also to the big problems that we have from global change and environmental issues that come with that.
Excellent. Thank you. And I've also met Genevieve, and she's great.
She's great. Yes, she's really great.
Is there anything else that you'd like to share with us today? If not, thank you so much for your advice. I know I've really learned a lot, and I'm hoping the people who get to watch this also can learn from your advice.
Well, thank you very much. No, that's basically, I wish you and all your colleagues and young students all the best in their professional life. And I'm sure you all will make a career one way or the other.
Thank you.